Hello and welcome to my channel, Classic Code Studios. I am KK Singh. So today I am going to discuss a topic linear regression in machine learning, which is the part of artificial intelligence subject code 843 CBC curriculum. So what is the linear regression? You must have studied in your junior classes like 9th or 10th, and this is very prevalent topic. So it's not new topic, rather I say. So a linear regression is a statistical method that shows the relationship between two variables x and y by fitting a linear equation to the observed data. And I hope you must have heard about linear equation, that is y is equal to mx plus b. The same equation I'm going to discuss here. The first variable is considered to be an independent variable, which I will denote as x, and other variable is dependent variable, which I'll denote as y. So dependent variable y trying to predict or explain y, whereas independent variable x that is used to predict or explain the changes in the dependent variable y. So a linear regression line has an unique equation of the form y is equal to mx plus v, whereas where y represents the dependent variable and x represents the independent variable. M determines the slope of the line of the graph and b is the intercept of the graph. We can use simple regression when we want to know how strong is the relationship between two variables, that is x and y, and the value of dependent variable at a certain value of the independent variable. What changes should it make? So if you see there's the linear equation like y is equal to mx plus b. So here m is the slope and x is independent variable, and here b is intercept. So if you see this graph, it shows the y is equal to mx plus b. This is the slope and the straight line, or you can say the linear regression line, and here b is the intercept. It is the intercept of y. So this is the equation which I have already discussed. Y is equal to mx plus b. Y is the dependent variable and x is the independent variable. M is the slope and b is the intercept of y. And for my project, I have taken uh, a project where uh, there are two variables, height and age, where age is the independent variable and height is the dependent variable. Okay, m is the slope as usual and b is the intercept. B is the intercept. So I have taken a data set of the age of the student. So where if the age is 0, height may be 20 centimeter. If the age is 1, then height uh, I might take 40 centimeter. If the age is 2 years, I can take the height as 60 centimeter and so on. So this data set I am going to use in machine learning project. So how to use it? Let's move to our Colab. Before that, I would like to discuss one more thing, that the least square method is form of the mathematical regression, and this is used to determine the line of best fit for the data set. So here you see this is the linear regression line, and beyond this there are so many points. This is actually scatter plot. So there are some actual values. These points are actual values plotted here below the line and above the line, but the best fit line, I see this is the red line, which you observe is the regression line. So the distance between the expected or predicted line and the plotted value or the actual value. So I should have choose the line which can be the best fit for the data set. The function of the regression model is to determine the linear function between the variable x and y, which can be the best describe the relationship between two variables like x and y. So here on x-axis, I am taking x as age increases, the height increases. So to calculate slope, I'll use the variable or the expression m is equal to sum of x dot y minus sum of x and into summation of y divided by number of samples multiplied by sum of summation of x square, that is the independent variable, minus sum of the independent variable whole square. And using the value of m, we'll be able to calculate b is equal to summation of y minus slope multiplied by summation of independent variable and divided by m. So let's move to our Colab to do the program. So here you see I am going to create this program in Google Colab, and I'm going to increase the size so that it could be visible. So here this is the screen. So I'm going to do this program in pandas, Python pandas. So first of all, I will like to import pandas as PD and import matplotlib.pyplot as plt and scikit class import sklearn dot linear model as lm, and I'm going to upload the dataset. Okay, I have uploaded the dataset. Now I'm going to create the data frame. So df is equal to pd dot read csv student dot csv. So my data frame is created and I want to print it also. So df and shift and enter. Okay, so here there's a little problem. I must say, what is the problem? First, I would like to see whether, okay, file is not there. So I would like to upload once again. Open. Now student.csv is here. And now I'm going to run this, whether it works or not. So yes, it is working. The same data set I'm going to use. And using this data set, I'm going to plot a graph. So plt dot scatter. So this should be the scatter graph. Not should be, but I'm going to. And this should be the double dimensional data frame, or you can say 2D data frame of variable age, comma, the dependent variable df dot height, that's it, and showing the data graph, scatter graph, and this is scatter graph. I'm going to change the color also, and color, and I'll give the marker. So I'm taking the color as red is equal to red, and marker, I'm taking this plus sign. Now I'll see. So it is the graph. So I think this is the best fit line, and so to predict the values, I have to train the model. So how to train the model? So before train the model, I have to create the regression object. So regression object is this: reg is equal to linear model dot linear regression. So your object is created. Now it's time to train the model. So I'm going to train the model is equal to reg dot fit, and df is age, comma, df dot height. So it should be trained. Yes, this is trained. And if I take a variable like this, and if I print trm, okay, perfectly fine. Now I'm going to predict. So how to predict? So I'll use trm dot predict. I'm taking the value age, because age is the independent variable. So I'm going to take age as age already 5, and I'm going to take age 9. So taking age 9, let's see what is the prediction. So it gives 177 centimeter. So this is your prediction of height. And since we have used linear equation y is equal to mx plus b, so we would like to check whether this formula gives the correct answer or not. So I am taking y is equal to mx m into x. X means my age variable, and b is your intercept, but it will not give anything because there is no value for bm. So first I would like to calculate m. M is equal to reg dot coefficient. So here this is the value of m, and the value of b is the intercept. So reg dot intercept, and this is the value of b. Now I can check whether the predicted height is the same as we have evaluated through the program or wrong. So y is equal to m. So m is here, m into x. X means the age. Age is, I took 9, m into df 9 plus intercept, that is b, and if I press shift and enter, it is giving some error. What is the error? Okay, okay, so this is the height and it should be the same, 177.78. So as the program has predicted, so it has predicted 177.78, and my formula is also showing 177.78, and it is in 2D list. So my program is correct, and the formula which I was using, y is equal to mx plus b, is also correct. So the formula which is y is equal to mx plus b is giving 177.780 height, centimeter height, and in the same way my program is also predicting the height 177.78. So this is your linear regression, and you can apply on many programs or many data sets. So hope you understand this program and you will apply on different data set as well. So this is for today, and we'll meet in the next video with some new topic. So till then, bye bye.